Hello everyone, welcome to new section. In this section, we are going to talk about COVID-19 exploratory data analysis. The first I'll tell you about the data understanding, then we will import the necessary packages and then we will prepare the data so that we can start with the plotting of these data. And the first plot we will do with worldwide COVID cases with the date and how it is increasing, and then we are gonna see it with the time lapse, and apart from that we will be also talking about the area plots of these cases, and then again on the maps with the heat maps and with the static maps images. All these plots are interactive plots. That means we can zoom in and then we can also zoom out to all these plots whenever you want. And then we will be talking about the new cases and deaths, confirmed cases, active cases, death per 100 cases, and all other parameters, whatever you can think about the COVID visualization. Then we will be talking about the scatter plot, and then we will move to the bar plot. Alright, so let's go ahead and run these plots in the runtime as well. These plots makes my computer a little slow. That is why I had not plotted these plot earlier. Now it might take a little time, but you will see there we will be having a bar plot, and these plots will be the plotted against all these countries. These plots could be a memory consuming plots, and these plots might eat up all the memory available in your computer. Although then we will move to the line plot, and in this line plot then we'll talk about how these cases are increasing day by day basis, and then we will talk about the growth rate after the 100 cases, and then after the 1000 cases, then 10,000 cases, and then we will also talk about growth rate after 100,000 cases. And then you can also control these cases one by one, and you can see how it is increasing. And then finally we will see about the tree map analysis, and then confirmed cases, death cases. Then we will talk about the first and last reported case. That's mean total time lapse between the first and the last cases. And then we will talk about the confirmed cases, country and day-wise analysis. And then we will be seeing here all those countries which have at least 10,000 data. 10,000 confirmed cases. And after that we have here a huge list, and then we will talk about COVID-19 versus other similar epidemics. And there we have SARS, MERS, Ebola, H1N1 and COVID-19 with the confirmed cases, death cases and mortality rate. So this is going to be very interesting lesson. I'll see you in next lesson where we will get started working on these files. Alright, now in this lesson we are gonna see COVID-19 exploratory data analysis. In the very first lecture we will take COVID-19 dataset understanding. I have already pre-processed this COVID data and it is uploaded on my GitHub repository. You can visit my GitHub repository and you see there I have a pre-process and raw data. Raw data is taken from Hopkins University Center for System Science and Engineering. And you can also visit this repository by clicking on this link, this upstream repository. There you will get, just a second. So this is the original data from where I have pre-processed this data and then uploaded it at my GitHub repository. Alright, so at my GitHub repository you will get the data, and there is two folder which I have processed it. One is a pre-processed data. In a pre-processed data, the data is prepared here country wise and country day wise, COVID-19 data clean. So this is a cumulative data of all the cases together with the latitude, longitude and country and as well as a date. And then there we have a recovered data and deaths, confirmed cases and the active cases. Then we have here a day wise. So this repository I am updating on day by day basis. So this repository is being updated from Johns Hopkins University Center for System Science and Engineering data. Alright, so let's go ahead and understand that data a little bit more. In this data, we have here the folders. In these 3 folders, basically I have taken their COVID time series, this data and this daily reports together to process it. And then in these we have there 5 CSV files. So these CSV files includes day by day cases in each of the countries along with their latitude and longitude. Alright, so this data has been already processed and it is available at my GitHub repository. You need to clone this repository. Once you clone this repository, this data will be available for our visualization purpose. Alright. And then we will be using here another package which is known as a Folium package. So Folium package will be used for map visualization. As you see there is an example. In this example, it's a map visualized there. So we'll be using this Folium to visualize corona cases worldwide on a world map. Alright. Along with this, we will be also using their Plotly. So Plotly is used to plot a dynamic plot. We can use matplotlib, Seaborn or pandas directly, but matplotlib do not plots in an interactive way. That means you cannot zoom in or zoom out. All those things are not available in matplotlib Seaborn. So those plots are static plot. So we'll be using here a Plotly for interactive plots, and Folium will be used for map plotting. You need to install these 2 packages, Python packages. You can install these directly from your Jupyter notebook with pip install Folium and pip install Plotly. Alright, now let's go ahead and import necessary packages which we will be using in this lesson. Alright, so the necessary packages which we will be using there, you can write there, imports. Alright, so we are gonna use here Plotly first. So you need to write there import Plotly dot express as px, and then we will be using here import Plotly dot graph objects as go, and then import Plotly dot figure factory as ff from Plotly dot subplots import make subplots. Alright, so we'll be using this px and go to plot our data in a canvas, and this will be used for setting some aesthetics, and then finally this make subplots will be used to plot in multiple subplots. Alright, so those multiple subplots like we did into our matplotlib, in the same way we will be doing here. Let's go ahead now import the Folium as well. Then we have here import Folium. Now apart from this, let's go ahead import here pandas as pd, and then import numpy as np, and then import matplotlib dot pyplot as plt, and then we will be here doing import Seaborn as SNS. I don't think we need Seaborn, so I'm not going to use their Seaborn. And then we will be also needing here matplotlib inline as well. Alright, apart from that, we also need some essential packages in this lesson. So that I'm gonna also import, like import math, and then import random, and then from date time import delta and time. Sorry, this is actually the time delta. Time delta is used to generate a custom dates like we did linspace in our Python or NumPy. Alright, so these are the other essential libraries. Now I'm gonna import here the color palettes. Why the color palettes need? We need these color palette because we will be also plotting the plots in multiple colors. So I want to set these color palettes. So we have here a CNF, and this is the CNF. In this CNF I have a color palette there, 393E46. Alright, 393E, then we have a 46, and then we have here DTH color palette. In this DTH color palette I have FF 2E63, 2E and then 63. Apart from that, we have also rec is equal to, that generally we will be using for rectangle, has 21BF73, 21BF73. Alright, so these color palettes actually you can change according to your color preferences. So these are the hex color patterns which I'm gonna use here just for the simplicity. So I'm gonna just write those name here so that you can also follow along. FE98 and 01. Alright, so these are the color palettes which we will be using. And finally, let's go ahead and write some commands to hide the warnings as well. So we can write those like import warnings and then warnings dot filter warnings. Alright, so I'm gonna filter those warnings which are just a warning, and I'm just gonna ignore those. Alright, so here we are ready with our import packages. Let's go ahead and run this cell. Once you run this cell, it will import all the necessary packages, and if it gives any error during the import, please comment below and in the question and the answer section. Then we will be seeing that what are the errors there, and so that we can resolve those. Alright, so this is all about in this lesson. Thanks for watching. I'll see you in next lesson where we will start data preparation. Alright, now let's go ahead and start data preparation. Before we start data preparation, one more package we need to import. So that is import plotly as py. And then we need to set this plotly to work with offline. Plotly works online and in offline versions. They are offline dot init underscore notebook underscore mode, and there you need to use connected is equal to true. So with this plotly will work. Sorry, I think there is a little mistake there. So with this plotly will work in offline mode as well. Alright, now we have everything ready. Let's go ahead and git clone the data set which I had shown you. Let me show you again, which is already available at my GitHub repository. Let me see, where is it? Well, I think it's not here. Let me get that data from here. So you can get that data from here directly, not a problem at all. So this is the data which we are going to git clone. Alright, so you can git clone this data. Come here and copy this link. And once you get those link, then you need to come here and write there git clone. Alright, and paste that one. So with this, what it will do, it will clone this repository where we have a latest pre-processed data. Let's go ahead and run it. Once you run it, then you will see here there is a new folder, and this new folder have this pre-process and raw data. So we'll be loading these pre-processed data, and these pre-processed data has taken from this John Hopkins data set. So we have taken this from there. All right, perfect. Now you have this one. Let's go ahead and run it again. Once you run it again, what you see there? You see there the destination path is already exit. That's mean if you want to update this repository with the new data set, then you need to first delete that current repository, which is this one, and only after that you will be able to again clone this new repository. So for that, what I'm gonna do here, I'm gonna remove that repository by using here a try, then os.system. All right, I think we do not have os. Let's go ahead and import that os as well. So we have here os.system, and then I'm gonna run following commands. rm, that means remove, rf means recursively, that means remove all the files, and then I'm gonna take this folder name which I want to remove. Why I want to remove? I want to remove it before cloning so that I can clone a new data set. All right, and if it already exists there, then in the expect, what I'm gonna say that, I mean if this COVID-19 pre-processed data set is not there, then I'm gonna print there file does not exist. All right, let's go ahead and run it. Once you run it, then you will see there is no such files or the directory there. All right, so now what I'm gonna do there, I'm gonna again run it. Once you run it, all right, now you see we have got this repository. All right, so earlier this repository was not there, but again we have got that. So this is the method where you can download the latest data. All right, so in the next lesson I'll show you how you can load those files which we want, those files which is in pre-processed folder, and then we can get started with our data visualization. So thanks for watching this lesson. I'll see you in next lesson. All right, now let's go ahead and inspect the repository where this data is downloaded. That's in a folder. So this data is available here, COVID-19 pre-process dataset, and there I'm gonna show you inside a pre-process. So inside a pre-process we have these 4 files, and in these 4 files we are having, let me open this one. So the country day-wise CSV. So there we have country, confirmed cases, deaths, recover, active, new cases, new deaths, and the new recoveries for all these countries. And this data set starts from 22 January, that's 22nd January. All right, and then there is latest data available for today. It's 9th of May. All right, perfect. Now let's go ahead, close this one, and sorry, I think I don't need to save it. Anyway, so we have here another one, that's the clean version. So this clean version is a clean version of time series data which is available at John Hopkins University. All right, so there we have this data, and one thing you notice here that there is a time, 2 different time formats are here, but not to worry, all these formats are handled automatically in other files and these will not create any problem. And then it has total day by day cases for all these dates. So today we have here 9th of May. All right, and the 2 extra columns is available in this file, which is longitude, latitude, and longitude, which is a coordinate, so that we can also find out the coordinates of that country or the province or state. And then we have here day-wise cases. So this day-wise cases is total the cases to that particular day for all the countries together. So it says that on the 22nd January, there were 6 countries affected from COVID, and those affected countries kept constantly increasing, and currently it is now around 187 countries where COVID-19 cases are registered. Alright, perfect. So these are the data set which we are going to read in our this Python notebook. So let's go ahead in this Jupyter, read those data set in this Jupyter notebook. So the first of all, I'm going to read that clean version of the data set that I can read with df is equal to pd dot read underscore csv, and it is inside COVID-19 pre-process data set. And then there we have a pre-processed, and then finally we have there COVID-19 data cleaned.csv. And I'm going to use here parse date so that I can parse the first column as a date. I mean a date column is there, so this will be parsed as a date. Alright, and if you run it and you see that df here, you will see, so this is the first column is parsed as a date, and there is other columns as well. The one thing you should also notice here is that there is NaN values in province and states. So these are the none values. So we need to also handle those none values, and those none values we can handle simply by changing here df province and state is equal to df province state dot fill na, and inside that I'm gonna fill here empty strings. Alright, so now you see this is clean version of the data. Alright, so as we imported this clean version of the data, now we need to also import other data. You see there is other data as well, like country day-wise, country-wise, and the day-wise. So we'll be importing these data in the next lesson. So thanks for watching this lesson. I'll see you in next one. Alright, now let's go ahead and import other remaining data. So those 3 remaining data which we need to import: country day-wise, country-wise, and day-wise. So to do that, I'm gonna just copy it and then paste it here 3 times. So those other three CSV repositories will be copied here, imported here actually. So we have here first country daywise.csv, and then we have here a countrywise.csv, but countrywise.csv do not have any columns as a date, so I'm gonna remove that one. And then finally we have here daywise. Alright, perfect. And this first one is country daywise, country underscore daywise, and the another one is, sorry, this one is countrywise, and then finally we have here daywise. Alright, so now these 3 other packages are imported here. Let's go ahead and see those packages. I'm going to just limit these with head. So we have here countrywise, daywise, and country daywise. Let's go ahead and see first few lines of those data frame. Like here we have a countrywise. Alright, and then here we have a countrywise, and then finally we have here a daywise. So all these are imported here. Now what I'm going to do here, I'm going to get the confirmed, recovered, and deaths from the DF. So you see there DF, inside this DF we have here confirmed, recovered, deaths, and the active cases. So those cases I'm gonna get there. So we have here confirmed is equal to DF df dot group by with date. So by date, all these will be grouped for all the countries. Then I'm gonna put their sum. That means it will create a sum for all those the COVID cases. And then finally, I'm gonna just take their confirmed cases. And then I'm gonna reset index here. Alright. Now if you see this confirmed, you will see there a day by day cases to all the countries. So by latest, you see there we have around 4 million cases, okay, by today across the world. This is the confirmed cases. And similarly, I'm gonna just copy it and then I'm gonna paste it for the recovered cases. Alright. And there I'm gonna pass their recovered. And then we have here recovered cases. So in this recovered cases, currently we have around 1.37 million cases are recovered. And then similarly, I'm gonna do for the deaths as well. So there we have deaths. Alright. So by today we have total 279,000 deaths reported till 9th of May 2020. Alright. Perfect. So let's go ahead and take just few lines of this head so that we can save some spaces here. Now let's go ahead and see if there is any none values present in our clean version of COVID dataset. So you can check that with is null and then sum. So with this we see that there is no null values present in this DF data frame. Alright, let's go ahead and see this DF data frame with the info. So this says that we have this date column which is parsed as date time, and then we have these two columns which is object, that means these are a string, and then latitude and longitude is a float version of the data, and then other four columns we have in integer format. Alright, now let's go ahead and finally do some query for a particular country in a DF. So df dot query, and in this query I'm gonna set here country is equal to US. Alright, and once you do this, you will see all the cases for the US country only, and there are 109 rows. That means since last 109 days the first case was reported into US. Alright, perfect. So this is all about in this lesson. Thanks for watching. I'll see you in next lesson where we will start with worldwide total confirmed, recovered and death cases analysis. Alright, now let's go ahead and do some worldwide total confirmed, recovered and deaths analysis. We already have those in confirmed.head, that's the worldwide confirmed cases. And after that you see there is tail. In the tail you will see their latest confirmed cases, and similarly we have in recovered.tail. So these are the latest recovered cases, and similarly you will get there deaths.tail and last five latest deaths. So this is the total confirmed, recovered and deaths. Now let's go ahead and do a plot of these latest confirmed, recovery and deaths on the scatter plot. So the first of all, we need to create a figure in Plotly. So that we can do with fig is equal to go, that's the graph object in Plotly, and there you need to create a figure canvas like we did into our matplotlib. So if you see there fig.show, so this is an empty plot. Alright, so we have got this figure in a Plotly. Now our task is to add here confirmed cases, recovered cases and death cases. So the first of all, I'm gonna add that fig dot add underscore trace. So fig underscore trace. So this is going to add here. Okay, scatter plot. Go dot scatter. Now in this scatter plot, we need to pass the x variable, and the x variable we have here confirmed cases. Alright, so on the x-axis, I'm gonna pass their date, and y is equal to confirmed cases, and there I'm gonna pass their confirmed. Alright, now we have x and y. Let's go ahead and run this and see what happens. So with this, we get here a simple plot of confirmed cases from day wise and the total cases on the y-axis. And currently it is saying on the May 9, 2020, there is 4.02 million confirmed cases of the COVID-19. Alright, let's go ahead and add some more data, the figure aesthetics. So there I'm gonna first change a mode. With the mode is equal to line plus marker. Alright. So this will change this line with the line and markers. So there we have actually lines and markers. Sorry, I think something is missing there. Let me see what is happening there. I think yes. So that mode should actually come inside the go.scatter plot. Alright. Now you see we have got here line and markers together. Alright, perfect. Now let's go ahead and change the color of this line and see what happens. After this mode, I'm gonna change the name of this line. I'm gonna say that this is confirmed cases. And then I'm gonna change the line color as well. So line color can be changed with the color palette line dict, and in that dictionary I'm gonna pass their color is equal to orange. Alright, let's go ahead and run it. Sorry, this should be the dict. Let's go ahead and run it. Now what do you see? You have got here a new line and marker together with the color change in orange. And apart from this, I'm also going to pass here the width of this line. You can pass that with width parameter. With this width parameter, you have width is equal to 2, let's say, by default. And if you want to increase the width with like a 4, now you see there the line width has been increased there. But here I'm gonna put it just 2 so that it can look so good actually. Alright, so this is for a confirmed cases. And similarly, what we can do? Similarly, we can do for the other cases like recovered cases and death cases as well. So I'm just gonna copy it and then I'm gonna paste it here. And now this is going to be for recovered cases. Alright, let's go ahead and make it recovered. And here we have, we have here recovered. Alright, and the name we also need to change here. That's the recovered. And let's go ahead and change its color as well. So for a recovery, I'm gonna pass their green color. Let's go ahead and run it. Once you run it, now you will see here we have got confirmed and recovered cases till now. And finally here we need to add the third parameter, and that's the third one is actually the deaths. So we have here deaths, and then finally we have their deaths, and similarly death is here, and we also need to change that deaths here as well. And then finally here this green, I'm gonna change it to the red color. Alright, now you see we have got here a very beautiful plot which have confirmed cases, recovered cases and death cases on this plot. And this plot you can actually zoom in if you want to this plot. So this is a very beautiful plot in Plotly. Then you can click on auto scale, then it will automatically scale these to default scaling. Alright, now let's go ahead and write the final piece of code to update this figure. So we can write that fig.update underscore layout. Alright, and there I'm gonna put there a title. The title I'm gonna put here worldwide COVID-19 cases, and on the x-axis, alright, x-axis tick fonts. So I'm gonna change those x-axis tick font size, that I'm gonna make it 14, and then y-axis is equal to, I'm gonna pass there a dictionary, and its title is going to be number of cases. Alright, let's go ahead and run it. Now you see here how beautiful plot is this one. We have here a number of cases, and there is the date, and then finally we have here a very interactive plots for confirmed recovery and deaths. So this is all about in this lesson. Thanks for watching. In the next lesson, I'll show you how you can plot case density animation on world map. Alright, now in this lesson, we are gonna see a cases density animation on a world map. So before getting started with the animation, we need to convert our date parameter. You remember that df.info. Inside that we have this date as a date time object, and this need to be first converted into an string format. So we are going to do that first. So we have here df date is equal to df then date, that should come like this, df date dot as type, and this as type we have str. Now this is converted into object type. You can check that with df.info, and there date is converted into an object type of the format. Alright, now let's go ahead and start plotting with the Plotly Express. So we'll be using here a Plotly Express. Earlier we had used Plotly Graph Object. Now we are going to use here Plotly Express. So we have already imported Plotly Express as px. So there we have figure is equal to px dot density. So there we have a density heat map, contour, and map box. So we are gonna use here density map box, and inside that df parameter, df data will be passed there, and then the latitude on that map will be plotted from the lat column. If you remember that df, you see there df dot head, inside that we had latitude and longitude, and longitude parameter is stored in long variable. And whenever I need to hover on the map, I want to show their country name. So hover name is equal to country. You see that a country name will be displayed there if we hover on a particular country. And then we want to make sure that what are the data which we want to see when we hover over the map, that's mean mouse. Okay, so whenever we hover this mouse over a map, we want to see their confirmed cases and recovered cases as well as deaths. And then it asks about what is the animation frame, that's mean how we want to change the animation. So that is going to be the animation underscore frame, and that is equal to date. All right, that's mean that animation will change according to this date. And then finally we have here color continuous scale. On this color continuous scale we have here a Portland color. So these are the predefined color schemes. And apart from that, we want to put here radius of that heat map there. So radius is equal to 7, and we do not want to zoom it, so zoom is equal to 0. And then finally, what should be the height of that graph? And height of that graph I'm gonna put there 700. All right, now let's go ahead and run it and see what happens once you run this. As soon as you run this, it gives you an error. It says that hover date, I think that's hover data actually. All right, and then it also says that there is keyword error into radius. Yes, radius spelling is wrong there, sorry. Now we have here radius. All right, so once you run it, you do not see anything. Now let's go ahead and see, type there figure.show. All right, so you get here a map, and you get here there is an animation on which we will be seeing the data, but we do not have a map here. Now we need to add the map information here, and we can add those map information with fig.update. So here we have a fig.update underscore layout. So we are gonna update that layout with the title is equal to worldwide COVID-19 cases with time lapse. All right, and then finally we have here fig.update layout, and inside that we have there map box underscore style is equal to, now I'm gonna put there open street map. So this is world map, open street map, and then I'm gonna put there map box center longitude. Okay, map box center longitude coordinate, so that is 0 coordinate. And let's go ahead and run it. Once you run it, now you are able to see our plot. So we have seen it on the, let me zoom out it first a little. All right, now you see there we have worldwide COVID cases with the time lapse. You can start this plot. Once you start that, it will start here from there, and the time lapse is showing there. And as the cases are changing, these heats will be changed there. And if you see there is a US in the US we had around 60 cases till the first week of the March. But now see how these cases in the United States are increasing, and there is another country, India. So there we have around the 1000 cases at the end of March. And then we have there China, how these cases are increasing in the China at different province. You do remember, so these are distributed with the province. That's mean if I am hovering this at different places, so this is not giving a complete China cases. So this is the cases state by state. So in the coming lessons, I'll be giving you a complete map where we will be seeing a complete cases country by country instead of state by state or province by province. You see there is inside this head we have this province and state. So according to that, these data is being displayed there. Alright, so this is all about in this lesson. Thanks for watching. In the next lesson, I'll show you how you can do a more data processing on the COVID-19 dataset. Alright, now in this lesson, we are gonna see the total cases in the ships. So there are many ships which got affected with the COVID, and we are gonna see that what are the cases impact on those SIP. Alright, so if you remember, we had converted this date column into an object in previous lesson. Now we need to again convert these date into a date time format. So we have there pd.to_date time, and there we have a df and then date. So it will again convert that df date column into a date time format. Now you can see there we have got it into a date time 64 nanosecond. Alright. Diamond Princess was a first ship which had got affected by coronavirus. Let's go ahead and do some analysis and see what are the other ships which had got affected by the coronavirus. Alright. So we are gonna see here, first of all, we are gonna take a ship Roj. So ship Roj is equal to df, and that is inside province and state dot str dot contains. So this dot str dot contains will find out all those rows which had grand princess. Alright, let's go ahead and see those ships rows. Those ship rows. So these are those ship rows. In fact, we can see those with df inside those ship rows. Alright, so these are the grand princess ship which had got the affected, and there is a date. Alright, and the status. And then after that, there is another name is also there which is being referred. So that is, let me copy it here and then paste it here. So instead of the grand princess, there is also a diamond princess. Alright, let's go ahead and see this one as well. So we have got here grand princess and diamond princess. Alright. Now this is inside these province and states, and similarly we can also check if there is any mention inside the countries as well. So we are gonna just copy it, and then instead of these province and state, I'm gonna change these to the country, this one, and here this last one as well to the country. So we have got here, whenever these grand princess or diamond princess is mentioned in a country and province and state column, then it will extract those rows. And then finally we have there there is one more ship which is df country dot str dot contains. Then we have here ms Jandam. Alright, so these are the total ship which had got affected by the coronavirus. Alright, now let's go ahead and get these data inside the ship data frame. So we have here ship data frame now. After that, let's go ahead and get those tables which are actually let's go ahead and update the table, actually the df, so that we can remove these ship out of those our countries. So df is equal to df, and here invert, that's mean true will be converted into a false and false will be converted into true. And then we have their ship rows. Alright, so the data frame also got updated so that province, state and the country should not have any information about the SIP. Alright, perfect. Now let's go ahead and get the latest cases from the SIP. So we can get those latest cases. SIP underscore latest is equal to SIP, and inside that SIP we have SIP and then date column is equal to max, and inside that we have SIP and then date column. Alright, so now we have here SIP latest. So this is the SIP latest information currently which we are having: Grand Princess, Diamond Princess and MS Jandam. So there are total 712 people got affected by the COVID on Diamond Princess, and then you see there is total 645 people recovered and 13 death has occurred, and still 54 people are active there currently. Alright, now let's go ahead and see these with a little styling, and we can get those style with SIP underscore latest dot style dot background. Alright, so dot style dot background underscore gradient, and CMap I'm gonna use there pastel R. Okay, pastel 1 underscore R. Alright, so here you see the darker color shows that a larger value for that particular row. Alright, so this is great. Now you see there everything, we are seeing it very nicely. So this is all about in this lesson. Thanks for watching. I'll see you in next lesson where we will cover cases over time. Thanks for watching. Bye bye. See you in next lesson. Alright, now let's go ahead and see the cases over the time with the area plot. Before we get started with the area plot, let's go ahead and see it with a simple plot. I'm going to create here a temporary variable temp is equal to df dot group by, and I'm gonna group it with the date. So once it is grouped with the date, then I'm gonna select confirmed, death, recovered and active cases. So there I have confirmed, and then I have their deaths. Finally we have recovered and then active cases. In those I'm gonna create their sum over the time, so it will be summed together, and then finally I'm gonna do here a reset index. Alright, let's go ahead and see a temp. Now you see there we have got a temp for a day by day, so all the data is available there: confirmed, death, recovered and active. And now I'm gonna get that latest data on the temp, so that we can get with temp is equal to temp, and then we have there temp, then finally date is equal to max. That's when the maximum value, get the maximum value from that date. Alright, so we have got here date, and then finally we are gonna here do a reset index, and then finally we are gonna drop the index which is not required. Alright, let's go ahead and see now temp. With this temp we have got here a latest value from this temp. Now there is another way also to get this temp, which you can directly get from the tail values. That's when the last tail is equal to tail 1, you can say that. Even if we comment that one, and if we say like temp tail 1, you will get there a same value. But you know what is the problem with this one? Let's say if this date is not in ascending or descending sorted format, in fact in ascending sorted format, then it is not always guarantee that you will get the latest. That's mean, let's say here the date is starting from 22nd January to 9th of May 2020. But let's say if this date got mixed up together, that's mean 9th of May 2020 comes somewhere in between, then if you use this tail formula, you will not get the last row. I mean, you will not get the latest value, but you will get the last row, but that is not 100% guarantee that that is the latest value. So that is why I am not using here temp.tail. Alright, let's again go ahead and use this method to get the latest value. Once we got the latest value, now we are going to create here a melt plot. So tm is equal to temp.melt, and then there are variables on which we want to show this plot. Okay, id vars, that is date. All right, and then here we have value variables, and the value which we want to show there, we want to first show that the active, and then we want to show their deaths, and then finally I want to show their recovered. All right, and then I'm gonna create here a figure is equal to px.tree map, and inside that tree map I'm gonna pass that tm, and path is equal to variable, and then I have here values is equal to value, and then the height of this plot I'm gonna make it 250, and then width I'm gonna make it 800. All right, and color underscore discrete sequence, actually discrete sequence color, discrete sequence color, which I want to give here. So the first one I want to give their active cases, then I'm gonna give their recovered cases, and then I'm gonna get their for a death cases color. All right, once you have this one, then you need to add this into the figure.show, but before that we need to put the data there. So fig, then dot data 0 dot text info, I'm gonna put their label plus text and then plus value. That's mean label and value will be shown there, and then finally we can show their figure.show. So with this, now you get the plot here, and it has active cases. Currently the total active cases is 2.3 million, and we have their total recovered cases, and then finally we have a total death cases in this plot. And if you want to save it, you can simply save this plot like this one. All right, and then you can see that plot. I think that plot should be somewhere here. Well, that plot I think is in download directory. Yes, it is downloaded here. Now you see that was the figure which we were seeing there. All right, perfect. Let me zoom it out so that you can see it very clearly together. All right, so now you can see it very clearly. We have active, recovered and death cases. All right, so this is all about in this lesson. Thanks for watching. In the next lesson, we will take it to the area plot. All right, now let's go ahead and take this plot area wise. So I'm gonna first read the variable into a temporary variable. I'm gonna group actually a data frame in a temporary variable. Temp is equal to df dot group by. So with this group by, I'm gonna group all the data with date by. If you are wondering that what is this group by, you see there, this is a pandas data frame grouping. So it group all the data with this date values. And then we can perform the operation like sum, mean, subtraction, etc. So if you do the sum, what it does, adds all the columns, numerical columns together with this sum. Even you can calculate their mean as well. But this is not a recommended way, at least for this example. But the later, if you need, you can do the grouping along with this date and for other columns. So this date has become there, this index, and with the reset index, then it becomes a normal column. All right, now let's go ahead and get only the recovered, death and active cases. So we have here recovered and then deaths, and then we have their active cases. And then we will be doing here a sum. Once you do this sum, then you will see there we have only recovered, active and death cases only for these day, okay, day by day. So it starts from 22nd January 2020, and there we have the latest case here. And after this, I'm gonna reset the index so that this date can become a normal column. So I can do that with reset index. Now this date has become here a normal column. Alright, now let's go ahead and create here temp.melt, get the data actually in melt format. So temp.melt id underscore where's is equal to date, and then we have here a value underscore variables, value variables data is equal to, we have there recovered, and then we have deaths, and then finally we have active cases. Alright, and after this, now we need to pass there a variable name. So variable name is their case. So this case will come into a legend format. So case is actually a variable name, and the values of those variables are recovered, death and active. Alright, and the value name, on y-axis, the data which it will show there, a value underscore name is equal to count. Alright, now let's go ahead and see the see this temp now and see what happens. Now if we see there a temp, it will show here that cases, recovered, active cases. So these are the count for each of the day. Alright, perfect. Let's go ahead now create the figure so that we can add these values into a figure. So fig is equal to px dot area. So this is going to be an area plot. I'm going to provide there a temp variable, and then x is equal to, we have there a date, and then we have y is equal to count, and the color will be changed according to the cases, and height I'm going to use here 600, and the title I'm going to use their cases over time, and then finally I'm going to use here color discrete sequence. If you remember, we have already given the color to these discrete sequences, recovered, and then we have a death, and then finally we have active cases. Alright, let's go ahead and update this figure with fig.update underscore layout, and inside that I'm gonna add their x-axis underscore range slider. Alright, so x-axis, and then we have their range slider dot visible is equal to true. So there will be a range slider which will be shown there, and then we have here fig dot show. Let me show you what is the range slider. This is a range slider. If you make it false, then you will not be able to see this range slider. Now you see there is normal case, and if we make it true, then you will be able to see. Let's go ahead and make this height to only the 400. Alright, now you see we have got the cases over a time in area plot, and in this area plot what we get the cases, recovered, death and active cases. And if you hover over this plot, area plot, you will see the cases along with the dates. So currently we have active cases on 9th May 2020, 2.369 million, and there are total 279,000 deaths, and there are total we have 1.3749 million recovered cases till this date. And with this slider, now you can even select some particular date. Alright, perfect. So this is all about in this lesson. Thanks for watching. I'll see you in next lesson. Alright, now let's go ahead and use this volume map to plot the worldwide cases on the world map. We already have installed this volume with the pip install volume. Alright, so let's go ahead, install this, start working with volume maps. Volume maps. Alright, so we start with temp is equal to df, and there we have df dot date is equal to max df and then date. What it does, it takes the latest data for all the countries, and then it is displaying here, and the latest data for all the countries are available for 9th of May 2020. So there it has a confirmed, recovered, death along with the latitude and longitude. Let's go ahead and create a volume map. We can create a volume map with m is equal to volume dot map. Then we have their location. And the location we are going to start with the 0, 0. That's the longitude and the latitude. Tiles. Alright. So the tiles means the map which we want to show there. If you don't know much about this, you can press shift and double tab. You will get all the information about those volume maps. So this is the complete description. So the tiles I'm going to use here, cathode positron. So that's the actually inside a single code. We have there cathode positron. OpenStreet, we have already used OpenStreet map, but here I'm going to use a different type of map. And minimum zoom, I'm going to set that to 1, and max zoom, that I'm going to set that only the 4 times. And then I'm going to set here zoom start is equal to 1. Then we have here a for loop I in range of 0, and then I'm gonna create with the length of temp. Then we are gonna plot there a volume circle. So we have there a volume dot circle, and the circle will be plotted on those positions where COVID cases are recorded. So we have their location. Location is equal to that we have inside the temp dot ilog, that's mean index location, for those particular I mean for those particular the country. And then I'm going to take that's the latitude, and then similarly I'm going to put it for longitude as well. So there we have longitude. After this, I'm gonna put their color. I'm gonna put their crimson color. Alright, so these are the inbuilt color mapping. So we have their crimson color. And then I'm gonna define here a fill type. A fill type, I'm also gonna define their crimson color. So the full color, its age, and underfilling will be with the same color, that's the crimson color. And after this, I'm gonna set here a tooltip. But before that, let's go ahead and see if we can see this EM. So this is the full EM map, and if you plot it, it says that there is no radius defined. So what we need to do, we need to also pass here a radius and the tooltips. So I'm gonna pass here tooltips first. Tooltip says that what are the information which we want in our map. So I'm gonna put there the country name, province, confirmed cases, and death cases. All right, perfect. So let's go ahead and put that. You can put that with the li. Li means that's the list actually. And then we have there the bold cases. That's mean actually that will be displayed into a bold. And then we have their name of that particular country. Now, how would you make sure that the name of that particular country get displayed? For that, we are going to convert the country name into the str format. So that we get from temp.iloc for that particular column, that is we are going to get from index, and then here we have a country. All right, now you see here we have got it for this particular, and then similarly I'm gonna put there a plus sign, and then I'm gonna copy it. Then after that I'm gonna paste it for the province and state as well, and there you will get province and state. After that again I'm gonna copy it, and then I'm gonna paste it here, and now I'm gonna provide their confirmed cases. And in that confirmed cases, we have their confirmed cases. And then finally, I'm gonna paste it for the deaths. Now we have the death here. Let's go ahead and provide the radius as well. So we have here a radius in the form of int temp dot iloc, that is for ith index. Then we have their confirmed cases. All right. Then after that, I'm gonna take there a square root of that particular radius, so that we can do with 1.0.5. And once it is done, then I'm gonna add here a map, that is add underscore 2m. All right, perfect. Now let's go ahead and run it. Now you should see, I think there is some invalid syntax. Let me see what is the error there. It says that, all right, I think the error is here. I need to put there, all right, a comma. Let's go ahead and run it. It might take a little time to show this complete plot, but now you see there is a very beautiful plot. So it has this world map, and the zoom starts with the 1, and then we can zoom it 4 times there. Alright, so this is the 4 times zoom. And then these are the countries. So we have here United States. In the United States, we have these total number of cases and other countries and their province there. And then we have their China and then their province. All right. Perfect. So you see the cases for all other countries. So the current cases in India, we have a 62.8 thousand cases and 2100 deaths has been occurred in this country. And they are in New Zealand, if you see, even if you can zoom it, in fact, in the New Zealand, we have total 1494 confirmed cases. Alright, perfect. So this is all about in this lesson. Thanks for watching. I'll see you in next lesson where we will start with confirmed cases with the animation. Alright, now let's go ahead and do a confirmed cases analysis with the Choropleth map. A Choropleth map is a type of thematic map in which areas are shaded in the proportion of the confirmed cases. A more number of confirmed cases, there will be a darker color. And if the cases are less, then there will be, a lighter color. So in the sense of a lighter color, it actually depends what type of the color mapping we are going to do. Generally, a larger case represents a more yellowish color and white color, and less number of cases represents a black color. That's mean black or blue color. Alright, let's go ahead and plot this Choropleth map. We are gonna plot this using Plotly Express. So fig is equal to px dot Choropleth, and there I'm gonna plot here country day wise. Do you remember the country day wise data which we had loaded earlier? So this is a country day wise data which had a country wise data, and the province has been removed, and then the confirmed cases, death, recovered, active, new cases, new deaths and new recovered are there. Alright, so we have here a country day wise, and then we have their locations is equal to country. Alright, so the location will be represented with the country, or you can say with the country name, and then we have their location mode, and the location mode we are gonna identify with the country names, and then it asks about the color mapping which we are gonna use there. So it's np.log and then country device. Alright, so based on this country device log data, lower data will represent a darker color that will be in kind of a black color, and larger the size of confirmed cases that will be represented into a brighter color. Alright, so with the country device, and then we are gonna pass there confirmed cases. So based on the confirmed cases. Alright, now apart from this, I'm also gonna show here what will happen when I hover my mouse over the map. So I'm gonna say here hover name. Now it's gonna represent their country name. Do you remember earlier when we were doing hovering over the country? So we were getting province or state name instead of a full country data. So we have here animation frame which we are gonna get here, that we are gonna get from a date. So we get that with country day wise and with the date. Alright, and then we are gonna convert it into string format. So .dt.strfr strf time. Okay, so that's the string format time, and that we are gonna represent it into the year, and then month. After that we are gonna represent it into a day actually. All right, so we have a day, month and year. After this I'm gonna give the name to this plot, and that name is cases over time. And then I'm gonna put here color continuous scale. All right, is equal to px dot colors dot sequential. Then we have there inferno. All right, so this is the color sequence which we are gonna use. Perfect. Now after this we are gonna update this figure. We can update this figure with fig dot update underscore layout. All right, in fact we are gonna use just update here, fig dot update, and then we are gonna use their layout underscore color axis, layout underscore color axis, and then we are also gonna see the color scale as well. So we are gonna make here true, and then we have there fig dot show. Let's go ahead and run it. Once we run it, it says that there is an error, I think. Yes, so that's the capital I. All right, so you see there with the color bar is there, and with this color bar 0 number says that there is less number of cases, and as this color bar becomes yellowish and more brighter, then we get the higher values. Let's go ahead and run this animation. Once you run this animation, as cases are increasing, the value at this color bar is also increasing. And if you hover here over the country, we have there a country, in this country China, and these are the, I think, the cases on the China, how it is writing there. And then we see there is other countries like US and see other countries. So these countries are becoming, the colors are becoming darker and brighter and brighter in fact. So as the colors are becoming brighter, that's mean the cases are changing there. All right, and these cases are on log scale. That is why it is just representing their 11, but the values are not that much of the 11. And if you want to make it out of that color bar, then how would you make that? Let me show you. You can just remove this log actually and run it. Once you run it, then you will start getting the real values of the cases. All right, so there you see the China cases are increasing there, and this confirmed says that the how many cases are there. All right, and then similarly in this India country we have only 3 confirmed cases, and for other countries, as you see, it is increasing, and there are color changing to other countries where cases are increasing. All right, now you can see very clearly that how these cases are changing. All right, perfect. So this is all about in this lesson. Thanks for watching. I'll see you in next lesson where I'll show you how you can more analyze about the confirmed death cases with the color mapping. Alright, now let's go ahead and analyze deaths and recoveries per 100 cases. But before that, we are going to first analyze confirmed and death cases on day by day basis. So You know, we have already the day-wise data. In this day-wise data, we have confirmed deaths, recovered, active, new cases, deaths per 100 cases, recovered per 100 cases, and deaths per 100 recovered cases, and number of countries. From this data, we are going to first plot here confirmed and death cases, and then we will see how we can plot death, recovered, and death and recovered per 100 cases. Alright, so the first of all, we want here fig c, that's mean for confirmed cases, px.bar. So this is actually px.bar plot in Plotly. Then we have there day wise. Then we have x is equal to date. Then finally we have there y is equal to confirmed cases. Then we have there color discrete sequence, and there we have active cases. Alright, so as we did it for confirmed cases, in the same way we are going to do it for death cases. So there we have death. Alright, let's go ahead and create here a subplot. Figure is equal to make underscore subplots. There we are gonna make rows, one row and then two columns. We are gonna use here shared x-axis is equal to false. That means x-axis will be not shared together. And then we have here horizontal spacing is equal to 0.1. Alright, then we have here subplot titles. In this subplot titles, we are gonna have here first confirmed cases. Death cases. Alright, now let's go ahead and add these two traces for confirmed and death cases into this figure canvas. That we can do with fig.add underscore trace fig underscore c. Then there we are gonna take the data of 0th column, and then it is going to be represented into row 1, and the column is equal to 1. Similarly, we have their figure dot add trace. Then we have their death cases. Sorry, that should be actually the data instead of date. Then we have here row is equal to 1, and then column is equal to 2. And then finally, we are going to update the layout with height. So we have there fig dot update underscore layout, and there I'm gonna set height is equal to 480. And then finally I'm gonna do there fig dot show. With this you will see DHT, I think that's the DTH actually. Alright, so now you see we have got their confirmed cases and death cases. What we can do, we can just reduce this height to 400, so that will look cool. And we have here confirmed cases and death cases. In these confirmed cases, these are the cases which are increasing day by day basis worldwide. And then finally we have total confirmed cases 4 million, and this is the death which is increasing there day by day. With this we can clearly see that the coronavirus is not gonna stop anytime soon, and the cases are still increasing there with the exponential, or you can say on the linear basis. In fact, it's not exponential. here it has become a linear, so it will keep increasing for some time still. Alright, so this is all about in this lesson. In the next lesson, I'll show you about the death per 100 cases recoveries and deaths on 100 recoveries. Alright, so see you in next lesson. Alright, now let's go ahead see a confirmed and death cases with a static color map. So to create a static color map, what we need to do, we need to again use Plotly Express. And we have Plotly Express imported in the with the px. So let's go ahead and write here fig_c, that's mean figure for a confirmed cases is equal to px dot Choropleth, and then we have here a Choropleth with the count. We have there a country wise data, and then we have there a location, and location will be displayed as country wise, and then we have their location mode, and this location mode is country name. Alright, so this is country underscore names. Alright, after this we have their color mapping. So color is equal to np.log, and there we have a country wise data, and then country wise with confirmed cases. Alright, and then the hover name we are gonna see with the country, and then we have here hover data is equal to confirmed. Alright, perfect. So this is for the confirmed cases, and let's go ahead and copy it and create for the deaths cases. Okay, so this is going to change to the deaths, and here a hover data will be displayed, which will be a deaths, and then we are gonna provide their country wise data to all those deaths. Alright, where the death is greater than 0 actually. Alright, then we have there a country wise data. Alright, so with this we have here our confirmed cases and death cases. Now apart from this, what we need to do, we need to get the data for the plot. So we have their plot, for the plot, there we have fig is equal to make subplots. Alright, and there we are gonna pass that rows is equal to 1, and then cols is equal to 2, and then we have their subplots titles, and in the subplot titles we are gonna say that confirmed cases and deaths. Alright, apart from that we are gonna provide here some more specs, and those specs we can provide in the form of dictionary, and that dictionary says that the type of the data which we are handling, that Choropleth. Alright, and then the another dictionary where we need to pass, that is the type for the death as well. So this is actually a same dictionary. Alright, so once you have this, now we have our two figures and confirmed cases, death cases, and this is a original figure canvas. So we are gonna add these traces in this figure. We can add those traces with fig dot add underscore trace, and then for this fig underscore c confirmed cases dot or you can say either you can use dot, otherwise inside square bracket data Alright, sorry, I mean the data actually there. And then we are gonna use that 0th axis, and the row is equal to 1 and column is equal to 1. Similarly, we can copy it and paste it here, and then instead of confirmed cases we are gonna use here death cases, and then row is equal to 1 and column is equal to 2 there. And then finally I'm gonna update this figure, so we can update that fig dot update, and we are gonna update it with layout underscore color axis. In fact, color axis is already the true, so let's keep that. And then we have there a fig dot show. Actually it says that there is an error. Well, so the error is coming from here. So what I'm gonna do here, I'm gonna just cut it, and then I'm gonna put it here inside a temp variable, and then I'm gonna put that temp here so that I can get the data. And then here at the color scale I'm also gonna put here a temp. Alright, now let's go ahead and run it. Now once we run it, we see something. FID is not, yeah, this is actually figure. Alright, now you see we have got confirmed cases and death cases, and then we have there a color bar. Let's go ahead and remove this color bar. To remove that color bar, with the figure dot update, and then we have their layout underscore color axis underscore show scale is equal to false. So with this we have removed that color bar, and now we can see very clearly that the confirmed cases and death. So this is really looking cool. I am sure you are learning a lot in this lesson about the COVID data visualization. Thanks for watching this lesson. I'll see you in next lesson, where I'll be doing deaths and recoveries per 100 cases analysis. Alright, now let's go ahead and see deaths and recoveries per 100 cases. And for that, we need to create here figure 1 is equal to px dot line. So we are gonna see a line plot this time. So line, and the data is day wise data, and at the x-axis we are gonna pass their date, and then on y-axis we are gonna pass their deaths per 100 cases. If you remember, we already have there a day wise dot columns. So these are the column names which we are going to use there. So we have used here deaths per 100 cases, that is inside y, and then we are going to use here color discrete sequence, and there I'm going to use their death. Okay, that's the DTH. Alright, so this is for figure 1. Then I'm going to put here figure 2. For a figure 2, which we are going to use there, that we are going to use their recovered per 100 cases. Alright, and then the color discrete sequences we are going to use for recovered cases. Alright, let's go ahead and copy it and paste it here. Now once we paste it here, now we are gonna see their deaths per 100 recovered cases. So let's go ahead, copy it here and paste it inside. Alright, so these are the 3 figures. Now we are gonna create here a subplot. So that subplot we can create with fig is equal to make subplots, and there we have rows is equal to 1 and column is 3, that's mean 3 column. We don't have any shared x-axis, so let's make it false, A shared x-axis means these axes will be shared together. That means these cases will be, axis will be the same for these two cases. And when we make this false, shared x-axis is equal to false, then we need to also give here subplots title. So there we have subplot titles, and there we are gonna make put here deaths. In fact, we are gonna put the same, actually the name there. All right, and then we have there recovered 100 cases, and then finally we have there deaths per 100 recoveries. All right, now we are gonna add these traces inside this figure. So we can add that fig dot add underscore trace. All right, so there we have fig1, and inside that we have data, that's the 0th column, and then we have their row is equal to 1, and the column on which we are gonna print that, that's the column 1. And then similarly I can copy it, paste it here, and then we have here figure 2, and similarly for figure 3, and the row is going to be same, but column is going to change here. All right, once it is done, then we are going to set here a figure height as well. So we can set that fig dot update underscore layout, and the height we are gonna pass there is equal to 400, and then we are gonna set there fig dot show, it will plot this figure. It says that fig 3 is not defined. I think yes, that should be fig 3. All right, now you see there we have got the 100 cases, recovered 100 cases, and deaths per 100 cases. But the one thing is not clear here. These are the mixed together, so we can just zoom out. Perhaps with the zoom out it's not gonna, yeah. So once I zoom out my Jupyter notebook, now you can see there very clearly how these cases are varying there day by day. So the death per 100 cases, how it is increasing. As the time is increasing, death was increasing, but after some time it started decreasing. And the recovery per 100 cases is there. It starts increasing, then it decreased, and then again it starts increasing. And death per 100 recovered, it decreased, and then a little increase, and then again decrement. All right, so this is all about in this lesson. Thanks for watching. In the next lesson, I'll show you how you can plot a number of new cases every day. That's mean if you see there, in the next lesson we are gonna see total the number of new cases per day and how many countries got affected day by day. All right, so see you in next lesson. All right, now we are going to see about the new cases per day and how many number of countries got affected per day. So we can get started as we did previously. We are going to use their plotly bar plot. So I'm going to plot here fig underscore c, that's mean figure for confirmed cases. Then we have their px, that's the plotly express, then bar plot. Then we are going to use here day wise data, and on the x-axis we are going to use their date, and on the y-axis we are going to use confirmed cases, and the color discrete sequence, there we are going to use their active cases color. And then we have their figure. All right, and once we had their figure underscore death is equal to figure underscore d px dot bar, then we have their day wise x is equal to date, and then y is equal to deaths. Sorry, this is not going to be deaths, but this is going to be number of countries. If you remember there, we had that number of countries. All right, perfect. Perfect, that's the y is equal to the number of countries, and then we have their color discrete sequence, and there I'm gonna use that DTH. Okay, that's the death actually. Alright, the one thing I remember here that this color is a little, the off color. Oh yes, so I have not changed that. So you can take the other colors from here as well. Like let's say the active cases, we have here confirmed death and recovery and the active cases. Let's go ahead and make some random number here. So I'm gonna make that with hash some number. I'm gonna just generate 6 numbers there. Let's go ahead and plot it. I think that's not gonna work here. That should be inside actually a list. Well, still it's not working. Let me see what's the error is there. This says that these are the error. Let's say if we can get this error. I mean, if we can update this to this aqua. Yes. Alright, so we have got here a different color for the death for 100 recoveries. Perfect. Now let's go ahead and create here subplot. So figure is equal to make subplots. There I'm gonna create that rows is equal to 1 and then calls is equal to 2. That's mean 1 row 2 column. And then I'm gonna do their shared x-axis is equal to false, and then we have their horizontal. Alright, horizontal spacing, we have their horizontal spacing is 0.1, and then finally we have their subplot titles. Now inside that subplot titles, the first I'm gonna put there number of new cases per day, and the another one is number of countries. All right, perfect. Now let's go ahead and add these two traces inside this figure. We can add that with fig dot add underscore trace, and inside that we have fig underscore c. All right, so fig underscore c there. Then we have their data for 0th column. Then we also need to provide their row number and then column number. Similarly, we are going to copy it and paste it here. There we are gonna provide column is equal to 2, and we also need to change this to actually this fig d, although this could be something else. So this is not this fig d is not the country actually, but anyway, so with this we have got it. And then finally I'm gonna put there fig dot show. All right, so with this what we get there, I think there is some error. Let me see what was the error. This says that the colors, I think we have mistake in color decision. Alright, so there we have the number of new cases per day and number of countries per day which has got affected on everyday basis. Alright, perfect. So this is all about in this lesson. Thanks for watching. I'll see you in next lesson where we will talk about top 15 countries case analysis. Alright, now we are going to analyze top 15 countries cases. So the first of all, I'm gonna write there top is equal to 15, and then I'm gonna make it a little larger so we can code it freely here. Then we have here fig underscore c is equal to px dot bar, that's in Plotly Express bar plot, and then we have there country wise. All right, country wise dot sort values. All right, so we are going to sort these values. First we are going to sort it based on the confirmed cases. All right, so sort it based on the confirmed cases, and then we are going to take here the top of 15 values, that's mean tail of those 15 values, which will be as a largest 15 values. All right, country wise. So that's the top 15 there. And then on the x-axis, I'm going to provide their confirmed cases. All right, confirmed cases. And similarly on the y-axis, I am going to provide their country. All right, and then the text information which will be displayed on this bar plot, I'm going to make that confirmed. And the orientation, so this is going to be a horizontal plot instead of a vertical plot, so I'm going to make that H, that's mean horizontal plot. And then I'm going to fix here color discrete sequence is equal to ACT, that's the active color. All right, so this is for a confirmed cases. Similarly, we are going to do it for death cases. So this is fig underscore d, and there it will be deaths, and there will be also death, and then finally this active will be DTH, and this text will be also death. All right, now let's go ahead and create first subplot so that we can visualize at least these two data together. So we are going to take their fig is equal to make subplots, and there we are going to analyze a lot of the rows there, so you can get those with country wise dot columns. So there are many columns which we are going to analyze. So basically we are going to create those their 5 rows and then 2 columns. And after that, I'm going to put their shared x-axis is equal to false. And the horizontal spacing, I'm going to put there 0.4, in fact 0.14. And apart from this, we are going to put their vertical spacing. All right, so we have their vertical spacing. Let me bring it to a new line there. So that's I'm going to provide there 0.1, and then I'm going to provide their subplot titles. All right, so for a subplot title, I'm again going to put it into a new line. We have their subplot titles. So for the first subplot title, we have their confirmed cases, and the another one is death case reported. All right, and then finally we are going to add those traces inside this figure. So that's the fig dot add trace. First I'm going to add fig c, and that I'm going to add with data with 0th column. Then I'm going to define that this should be a column 1 and row 1. All right, so that should be the row 1 and the column 1. That's for the confirmed cases, and let's go ahead and plot it for in the row 1 and column 2, that is for death cases. All right, and then finally I'm gonna update the figure. You can update the figure with fig dot update underscore layout, and inside that I'm gonna put the height is equal to 400, and then we have fig dot show. Let's go ahead and show this figure, With this figure, what we get? We get, actually this should be, let's go ahead and make it a little larger, because there are 5 rows and all those 5 rows will not be able to adjust in just 400, but make it, let's say, 3000. All right, so with this, what you get there, you get confirmed cases and death reported, but there are many other plots are left here because we have not plotted others like recovered, active cases, new cases. So in the next lesson, we will be plotting all those as well. So thanks for watching this lesson. In next lesson, we will continue it to other columns as well. Bye bye. See you in next lesson. Alright, now let's go ahead and add other columns as well. So we are going to add here recovered and active cases. And for that, what we can do, we can simply copy it. And let's go ahead and paste it here. And then here we have active and the recovered cases. So this is going to be active, that's the A. And then here we are going to pass, that's the recovered cases. So for the active cases, that should be actually the active, and this X should be also active, and then the text should be, that text also should be active, and then we have their recovered cases. So this should be recovered. Let's go ahead and copy it, paste it here as well, and then finally here. What we get here for the recovered cases, we need to pass here the sequences, that's we have their rec. Alright, perfect. So we have active cases, and then we have, actually this was not the right decision to put this sequence there. What we can do there, if you remember here, we had CNF for the confirmed cases. Alright, so let's go ahead and make that CNF, and that's the death. There we have active cases, and then finally we have here recovered cases. Now we need to add those traces here. Let's go ahead and add those traces here. So we have there for active cases A, and then for recovered cases. So what I'm going to do here, I'm going to put the recovered cases first and then the active cases. So in this recovered cases, I'm going to put their row is equal to 2 and their row is equal to 2 as well. And then I'm going to pass there a new title. So there the first one is actually the recovered. That should be recovered cases, and then we have their active cases. Alright, let's go ahead and run it. Now once you run it, you will get their death, confirmed death reported, confirmed cases, death reported, recovered cases, and active cases. Let me see what is going wrong here. I think these confirmed and death cases has gone a little wrong here, perhaps. I think I think something is wrong. Let me see what's wrong here. What we can do, we can make it again active cases and then see what happens there, perhaps. Well, so all those comes like active cases, this death and this one, that should not have like that. And then we have their death cases, then let's say put it to the, this is the recovered cases, that's okay. We are gonna change here for the active cases, so I'm gonna put there has 43, 43 and 43. Let's go ahead and run it. So we get it here. This is the active cases. We have their recovered cases and confirmed cases, and then the death cases. Still it is not resolved. Alright, so it seems there is some bug inside that. Anyway, if you are If you are also getting this kind of a bug, you can create a question in Q&A section. I'll try to answer those questions. But in any way, you have here confirmed cases, death reported, recovered cases, and the active cases. So you see this chart is led by the US, and currently around it has 1.3 million active cases in United States. And I think it seems the data is getting same for the death reported and confirmed cases. Let me see what is wrong. I think something is wrong here. Yes, so that's the wrong is here. So that should not be like that. So this is for confirmed, then we should plot it for the death here. Alright, so let's go ahead and run it. Now we get here. Alright, so we have here confirmed cases, death reported, recovered cases, and the active cases. Perfect. So this is all about in this lesson. Thanks for watching. In the next lesson, I'll show you how you can add more plot in this subplot, like new cases and cases per million people. Alright, see you in next lesson. Alright, now let's go ahead and add their death and recovery cases per 100 cases, or you can say per 100 confirmed cases. So those I'm gonna add here, that you can do with fig. Sorry, you have here a fig underscore DC. DC means here death and death per cases. Okay, so that's mean death per 100 cases. Then we have a px dot bar plot, and then we are gonna put there a same like country wise information. In fact, I'm gonna just copy it and paste it here. Whenever you are doing copy and paste, you need to pay their extra attention, so that you should not left any values which is a previous value like we did here. Anyway, so the first one is death per 100 cases, and then we have here recovery per 100 cases. So we need to get here death per 100 cases. That is here. Copy it. Death per 100 cases. Alright. And then we have here, and we also need to change here this color bar as well. So I'm gonna just put here some random color like F8 43 F8 4351. Alright. And then the next one we have here recovered per 100 cases. So there we have recovered per 100 cases. This one, copy and paste it here. Copy and paste it here. And after that we also need to put here some other color here. So I'm gonna just put some random color here like A45 and 98. Alright, so we have now our death per 100 cases, recovery per 100 cases. Let's go ahead and add those here. You can just copy it and paste it here. So we have here death per 100 cases and recovery per 100 cases. That's going to be row 3 and row 3 column 2. Alright, let's go ahead and run it. Once you run it, what do you see? I think these are the... Let's go ahead and put some horizontal spacing a little more. Put it here 0.2. Alright, and let's go ahead and remove these vertical spacing to 0.5. Alright, so now what we have there, we have confirmed cases, death reported, then we have here recovered cases, active cases, and finally we have added their new cases, although we have not added it the titles. So let's go ahead and add those titles here as well. So the new title which we had just added there, that's the death per 100 cases, that you can paste it here. And then finally we have recovered per 100 cases. Alright, let's go ahead and run it. Then you will see there you have got death per 100 cases and recovered per 100 cases. Alright, now in the next lesson I'll show you how you can add death per 100 recovery and cases per million people and all other things. So I'll see you in next lesson. Alright, now let's go ahead and get started with new cases per day. I mean new cases in the per countries, and then also get started with the new cases per million people. So I'm gonna just copy it here and then I'm gonna paste it here. Now once I paste it here, the information which we are gonna first change their figure underscore DC to the new cases, that's the NC, and then I'm gonna put there the population. Okay, so the fig P. Alright, so there we need to pay a little extra attention, although with the new cases, fig new cases. Alright, so there we have a new cases. There we need to copy this new cases. Alright, so there we have new cases, and inside that we had country-wise dot sort values, and then new cases take top 15 values, and then we have their death per 100 cases, that's the X, but here we are gonna take the new cases and Y is country, and then the text which we are gonna put there new cases, and then again we are gonna just create here some random values. Alright, and in the next one we have the cases per million people. Alright, so let's go ahead and copy it. The cases per million people. We need to pay here a little extra attention on cases per million people. There we are going to first create a temporary variable temp, and there country wise. Alright, and inside that country wise, then we are gonna take their population. Only those countries which have a population around 100 million. Alright, so these are the countries. The total it's I think the 1 million. So the countries which have a population more than the 1 million, so we are going to consider only those countries, and then we are gonna put here a temp sort values based on the cases per million people, and then x-axis is also going to be the cases per million people, and the text is also going to be the cases per million people, and I'm just gonna create here some random values for a color, and then finally we are going to add here the first cases per million people, and before that we had the new cases. Alright, perfect. And after that the final step which we are gonna do, that we are going to add those traces here, fig add trace, and there we have new cases, that's the NC, and that is going to be in row 4, and then finally we have their cases per million population, that is also going to be a 4. Let's go ahead and plot it. Once you plot it, it might take a little time, then you will see here we have got new cases and cases per million people. This is fantastic, and these plots looks really cool, and I'm so much happy that these plots are great. I mean these plots are looking great. Alright, so this is all about in this lesson. Thanks for watching. In the next lesson we will start with the week changes and how the percentage, I mean the cases percentage increases week by week. See you in next lesson. Alright, so we have reached into the final part of this subsection where we are going to add the final plot there, 1 week % increase or 1 week changes. So let's go ahead and do that there. So we are going to first take the 1 week changes and then 1 week % changes. So we are gonna add here. Let's go ahead and copy the first one. We have there 1 week change. Alright. So we have there 1 week change. In that, what we are going to do, in fact, we need to put it, in fact, let's go ahead and copy it here and paste it here, then cut it here. We have, yes, so the first one is week change, that's the WC. Let's make it WC, and instead of this new cases, I'm gonna make there 1 week change, and then we have X is equal to 1 week change as well, and inside this text we have there 1 week change. Apart from this, let's go ahead and make here some random color. I'm just gonna change a little this random color, and then finally we are going to take the final one, 1 week % increase, copy it and paste it here. So what we are going to look here, we are going to look there where the populations are greater than, where the new confirmed cases are greater than 100. So there I'm gonna put the confirmed cases which are greater than 100. That means it will only consider those cases where cases are confirmed cases are more than 100. And then we are gonna sort the values 1 week % increase, and then we are gonna put that here inside this X, and then we have text there as well. Let's go ahead and change this color a little. I'm gonna just make it 0. Perfect. So we have here prepared the data. We have WC, and instead of PIGP, we need to make it a % week increase. So make it WI. All right. So let's go ahead, copy it and paste it here. Once you do this, then we are gonna make here WC, that's the week change, and week increase in percentage, or WP was also right name. There we have row 5 and there row 5. All right, let's go ahead and run it. Once you run it, you will see there we have got a confirmed cases and death reported, recovered cases, active cases, death per 100 cases, recovered 100 cases. Then we have there a new cases. All right, and then we have there a cases per million people. All right, and then finally I think we have missed this last one. Let's go ahead and put the, yes, so we have missed that here, 1 week change. We are gonna put there 1 week change, and then we are gonna put there 1 week % increase. Perfect. So now you see there we have all these very nice looking plot. I think 1 week % increase is there. It seems we have missed something still. Let me sorry. Let me see what we are missing there. I think that's okay. WC and the WI data. So the new data is being added there. 1 week change and 1 week % increase. That's okay. Do I have anything here? Yes, we are missing actually the comma here. All right, now let's go ahead and run it. Then you will see here we have got there 1 week changes and 1 week % increase. If you zoom out this plot a little more, then you will be able to see here a better plot. All right. So these plots are a far more better, which we were seeing earlier. All right. So this is great. All those things are great, really. It looks really cool to me. Alright, so this is all about in this lesson. In the next lesson, we will start with a scatter plot for deaths versus confirmed cases. Alright, so in this lesson, I'm going to show you how you can save the images, okay? And to save the static images of Plotly plots, you need to first open Anaconda prompt in administrator mode, then install, let me copy it first. Then you need to, then you need to install here Conda, Plotly, Orca and psutil requests. Alright, run this command. I'm also gonna put it here so that you can install it later. Alright. So it will take a little time to complete its installation. Just wait for some time so that it can complete this installation. Then we will start saving the static images. Alright. Alright, so the installation is successfully executed. Now we need to create a folder here. You can create that with os.mkdir. So we need to first check if that folder does not exist. Then if not, os.path.exists this images. Then os.mkdir, that's mean make a directory, and the directory which I'm gonna make here, images directory. Let's go ahead and run it and see this. There we have images directory. Now it is empty directory. Then our task is to save the image which we had drawn in previous lesson. This is a figure image. We can save it with fig.writeImage. And then I'm gonna pass here the path where I want to save this. I want to save it inside images.figpng. This is a large image. It might take some time to complete its saving. And once it is done, then we can go in this main directory. I mean COVID-19 EDA images. There it should save. Alright, so this has saved this image successfully here, fig.png. Let's go ahead and open this image here. Click on this one, and then you see their image, confirmed cases with death reported and recovered cases, active cases, all these things has been saved here. Alright, perfect. So this is how you can save a PNG image, and in the same way, if you want to save the JPEG image, that's the JPG, you can also save that one. With this you can save their JPEG image, and if you want to save it as a PDF, then you can also save that as a PDF. You can put their PDF. Alright, so these are the various ways to save this image there, and here we have a PDF format as well. It might take some time to open this PDF. Well, so what I can do, I can open this for you in the, let me see if I can open this for you in my the PDF reader itself. Well, so you see there we have this image in the form of the PDF, and this PDF image is really looking cool, and in fact this is in high quality image. You see there, so this PDF is looking really very high quality image. Alright, so this is the way how you can save the images, and apart from this we have their JPEG image as well. Let me show you that here. So this is the JPEG image, alright, but you see the PDF image was really looking cool, way better than this JPEG image. Alright, so this is all about in this lesson. Thanks for watching. I'll see you in next lesson. Alright, so now I'm gonna do a scatter plot for a death versus confirmed cases. As we have been doing with Plotly Express, we are going to do the same thing here as well. Figure is equal to px dot scatter, and there we have country wise dot sort values, and the values which we are gonna sort, that is by deaths, number of deaths from ascending to descending. So what I'm gonna put here, ascending is equal to false, that's mean it will be sorted into a descending format. So I'm just gonna put there ascending is equal to false, and then I'm gonna select the first 15 actually values that you can select from ilog is equal to ilog, and then from the 15 location. Alright, and all the columns. So this is going to select first 15 rows. If you are getting confused here, what you can do, you can just copy it and then you can paste it here. With this, what you will get here, you will get there the countries death wise, top 15 countries death wise. So the another way to do this, what you can do, you can put their head and with the 15. Alright, so there you get the same values, and this is the one way. And again, let me copy it and paste it here. Then this is the another way. Alright, so you see essentially these values are the same which we are having. So what we can do, instead of writing this complicated code, I can just simply put that here, so that I can remove those complicated part of that code. And then I'm gonna put here top is equal to 15, and then I'm gonna put their top. Alright, so this is the one way. Once you have got this one in a scatter plot, that's the data. Then there I'm gonna put the x value. So on the x value, I'm gonna put the confirmed cases, and on the y-axis, I'm gonna put the death cases. So death versus confirmed cases scatter plot, and the color I'm gonna select here a country by color. So the color will be changed for various countries. I mean, it will be different country by country. And then the size of those scattered dots will be decided by the confirmed cases. So the more the confirmed cases, bigger will be size. Alright, and the height I'm gonna put here 700. Alright, so the text I'm gonna put there a country. So the country will be displayed just beside those dots, and then I'm gonna put on the log axis. So the x will be plotted on log scale. So that's gonna be true here, and similarly for y as well. So that's gonna be true here as well. And after that, I'm gonna put here a title. So the title name I'm gonna say the deaths versus confirmed cases. Alright, and these cases on log scale. Cases are on log 10 scale. Alright, so once you have this figure, then we need to update this figure. So fig dot update underscore trace, and there what we are going to do here, in fact underscore traces, fig dot update traces, I'm going to put their text position. Alright, so where we need to put these text position, in fact that should be inside these quotes, a single quotes. Then the text position, I'm gonna put those text position top and center. Alright, apart from that, I'm gonna type there fig.update layout instead of traces, and inside that I'm gonna put the show legends is equal to true. I'll show you later how you can make it false. In fact, that's show legend. And then we have fig.update traces, update layout. Then we have here x-axis underscore range slider underscore visible, is equal to true. And then I'm gonna type there fig.show, and once you write that, you will see there is plot death versus confirmed cases, and these cases are on log 10 scale. There we have a legend, and we do not want this legend, so I can make it false here, and that's a mistake there. And now the legend has been removed, and you can see here it very clearly the cases, death versus confirmed cases. Let's go ahead and decrease this size a little, make it 600. Alright, so now it is visible with a little more. Alright, and you can zoom these. Alright, so there is a slider with this range slider. You can zoom it, and then you can also auto scale all these things together. So there is death, and you have there a US death is really very high, and the confirmed cases. And apart from that, you have there United Kingdom, France and Spain. So these comes here together. And then finally you have there Brazil, Germany, Turkey, Iran, China, Canada, Belgium, Netherlands, Mexico and the Sweden there. So we can clearly see that there is the cluster here, in fact 3 cluster. The one cluster is this one. Then you can see these are some other type of the clusters where the confirmed cases are large, but the deaths are really low for these countries. And then there we have US, where the cases are more than 1 million confirmed cases, and the death is also going around, yes, it has around 80,000 cases there. Alright, perfect. So this is all about in this lesson. Thanks for watching. In the next lesson, I'll show you how you can more evaluate about the confirmed death, new cases versus country and the date wise using various plot. I'll see you in next lesson. Alright, so in this lesson, I'm gonna show you confirmed death, new cases versus country and date. So we'll be first taking a bar plot here. Let's go ahead and take the bar plot there. So we have here a fig is equal to px dot bar. Alright, then we have country day wise data, and in this country day wise data I'm gonna pass x is equal to date, and then y is equal to confirmed cases. Alright, and then finally we have their color. I'm gonna select as country, and then finally I'm gonna put their height is equal to 600. Alright, and the title I'm gonna use there a confirmed cases. Alright, and then the color I'm gonna use their color discrete sequence. So there I'm gonna use their plotly color, the plotly colors. So there we have px dot colors dot, there we have cyclical. Okay, so this is the cyclical color, and then we have their mygbm. Alright, so this is the one color. Then we have their fig dot show. Alright, So once you do this, you will see there the confirmed cases plot, and the color bar will be the taken from the cyclical color. That's when there will be a continuous color which will be plotted there for various countries. So it's a kind of a continuous color scale, and from that it will be taken. Now you can see there very clearly that, so that is taken from those continuous coloring. So there is a confirm, and then there is a country. So this is the legend, a country by country, and then it is saying that how the day by day, how what is the country contribution. So there we have the US country contribution. So this actually legend is too large, so it cannot be accommodated. So only the first few countries are shown here, which is sorted by in alphabetical orders. So the highest country which has dominated in confirmed cases is US. There we have UK as well. We have Spain there. We have Russia as well lately. And then there is highly increment cases in Turkey as well. Then there is Italy. Okay, so that's the Italy there. And then we have Germany as well, and France. So with this plot, you can see how much these other countries has been contributed in these confirmed cases. Alright, let's go ahead, copy this. Once we copy it, now we are going to plot it for the death cases. Alright, so there I have deaths, the country, and then the confirmed. Instead of this confirmed, I'm going to put the deaths. Let's go ahead and run it. Once you run this, then you will see for the death cases. Alright, so this bar plot actually is very high in memory consumption. So it's it will take some time, and it has made my computer slow. So it is a little hanging. But anyway, we are able to see here. We can see there are death cases as well. Alright, so here we have death cases, and in this death cases, we have there again US. Most of the death happened in the US, then United Kingdom, then there is a Spain, and similarly there is Italy, and then there is a France, and Iran is also there, and then lately the Brazil has been also, the death number has been increasing in the Brazil as well. Alright, now let's go ahead and take for the recovered cases as well. So what are the countries which have high recovery cases? Then there we can put recoveries. Alright, so I think that's the recoveries or recovery, I'm not sure. Let's put, then we'll see there. I think it's a recovery. I have just forgotten this name. Alright, so I'm going to put it here. Let's go ahead and plot it. I think it's a recoveries. Still we do not have that recovery. Yes, that's actually the recovered, sorry. So we have their recovered cases. Alright, so let's go ahead and plot it. Then we will see their recovered cases. Just wait a second, it might take a little time. My computer is hanging here, so it took a lot of the memory. Yes, so in the recovered cases, US, the recovery has been increased there. There is a Turkey and other countries as well. Alright, now let's go ahead and plot the new cases as well. Sorry. So for the new cases, what I can do, I'm just gonna copy it, and then I'm gonna paste it here, and then I'm gonna put their new cases. Alright, so there we have new cases. Let's go ahead and run it. It will again take a little time to complete its process, and then it will show you a new cases in the form of bar plot, and those will be stacked together. So these are the new cases, how these new cases are coming there. All right. So mostly the new cases, this is how these new cases are coming there. All right. So these new cases are reported how. We might not have the data for the United States in the new cases for these sometimes. So this might not be the, I don't think this is correct. Anyway, so this is the data what we are having, and this is the way how you can plot and visualize these COVID data in various ways. Alright, so this is all about in this lesson. In the next lesson, I'll show you how you can do a line plot and you can visualize these cases with the line plot. Alright, so now once again we are going to analyze those previous plots with the line plot. So there we can do with fig is equal to px, that's the plotly express dot line. Earlier we had used bar plot, but now we are going to use their line plot with the country day wise, and on the x-axis we are going to provide date, and then on y-axis we are going to provide the confirmed cases, and the color scale which we are going to provide, that's going to change country wise. All right, and then we have their height is equal to 600, and then we have their title is equal to confirmed. All right, and then we have their color discrete sequence is equal to px dot colors dot cyclical dot my GPM. All right, and then we have their fig dot show. So with this we will get there a line plot, and this line plot will show you that what are the confirmed cases and how these confirmed cases are increased, okay, in the form of line plot, and what has been the contribution of other countries in this case. All right, now let's go ahead and see the plot for other cases as well. Instead of only the confirmed cases, I'm also gonna see there for deaths cases as well. So there we have deaths, and after this I'm also gonna see this for recovered cases as well. Alright, let's go ahead and run it. Now you will get for confirmed death and recovered cases. So you have their confirmed cases in a line plot, and then you have their death. Alright, so the maximally it is being led by United States. Alright, and then you have here recovered cases, and United States is also having high recovery there. Alright, so this is all about in this lesson. Thanks for watching. In the next lesson, I'll show you how you can calculate the growth rate after the 100 cases in each of those countries. I mean in each of these countries. Alright, I'll see you in next lesson. Alright, so in this lesson I'm going to show you how you can calculate a growth rate after 100 cases in each country. Of course, we can calculate in only those countries which have at least 100 cases. So let's go ahead and get those list of those countries which have more than 100 cases. So we are going to use here country day wise data, and there we are going to get the confirmed cases which have at least 100 cases. Alright, so these are the countries which have at least 100 cases. You can see these countries by here, GT100. And if you want to see the list of countries which have at least which do not have more than 100 cases, then you will get these countries which have currently the less than 100 cases. Alright, so we are interested in only those countries which have at least 100 cases, and we are also gonna take there only the country name. Alright, sorry, we are gonna take there only the country name, and with this you will get their country name. But we don't need all the countries. I mean, we need all the countries but not the duplicate values. So we are gonna get here with unique command only the unique countries. I mean, the list of countries will be printed here. So these are the list of countries, and after this I'm gonna create here a temporary variable that's inside a temp is equal to df. Now that's the original data frame. Inside those original data frame, if you remember, we had df. Let's go ahead and take head of this df. So we have this df, and now I'm gonna take the countries. Alright, so this df have there the country, and those countries, alright, so is in GT. I mean, we are gonna select those countries which are inside this greater than 100, GT underscore 100. So sorry, I think we have got the 200 here. So with this we will get the data for all those countries which have which are present in this GT 100. Alright, I think there is some error. Let me see what's the error here. Alright, so we are gonna fix it into the next line. So how we are gonna do here? We are gonna put there a temp is equal to temp dot group by. Alright, so with this what happens? We get there a country, and then we are also gonna group by with the date as well, and then we have their confirmed cases. Alright, so we have their confirmed dot sum. Alright, and then we have their reset underscore index. Alright, and then we are gonna put their temp is equal to temp, and then select only those country. Alright, so temp confirmed cases which have more than 100. Alright, and now let's go ahead and see this temporary. So in this temporary data we have the confirmed cases which have countries like Afghanistan, Zambia, etc. So these countries have at least 100 cases. Alright, yes. Now what we are going to do, we are going to take the minimum date, alright, from where these 100 cases were reported. So that we can get with min underscore date is equal to temp dot group by, and there I'm gonna group it country wise, and then I'm gonna take their date, and then I'm gonna calculate the minimum date. Alright, so the minimum date there, and then I'm gonna reset the index, reset underscore index, and then I'm gonna put their mean date dot columns name is equal to, so the first column is country, and then we have their minimum date. Alright, so let's go ahead and see this mean date. With this we get there a country, and the minimum date, that's mean the date when 100 case reported in these countries. Alright, now what I'm gonna do here, so now I'm gonna calculate the data from those dates, those minimum dates. Alright, so I'm gonna put there from 100th underscore case is equal to pd dot merge, and inside that I'm gonna put their temp, that's the temporary variable. then I'm going to pass their minimum date, and then I'm going to merge this on the country data. All right, perfect. And then from 100th cases, all right, then I'm going to put their end date. I mean, how many days has been from the 100th cases of that particular from that particular country. So there I'm going to take the from 100th case, and then I'm going to take their date minus from 100th case, then I'm going to take their minimum. All right, so that's the mean day mean date. From this minimum date, what happens, we get the total number of days passed from this minimum days to this current days. All right, now let's go ahead and visualize it. You can get that like this. So it has how many days has been since then. All right, perfect. Now we have this one. After this, what we are going to do, we are going to plot it. So we can plot it with fig is equal to px dot line, and then we have from underscore 100th case, then on the x-axis we have their end date. All right, and then on the y-axis we have confirmed cases, and then color is equal to country, and then title is equal to end date from 100 case. Then we have their height is equal to, I'm going to put there 600, and then finally I'm going to put there fig dot show. So with this we will see their figure, and that's the end date, and there is the days reported when first 100 cases touched by the China, and then it has taken over by the United States, and as the days increases, the total number of confirmed cases kept increasing for the United States. And we have a spillover graph for other countries here, and then we have here China and the other countries. All right, so the Chinas have around the COVID cases from more than 100 days, and after the China we had the South Korea, and there is Japan as well. Then we have Italy and all other countries. All right, perfect. So this is all about in this lesson. Thanks for watching. I'll see you in next lesson, where I'll show you how you can work with growth rate after 1000 cases. Alright, so in this lesson I'm going to show you what is growth rate after 100 cases in all the countries. So this is almost similar which we did earlier. So for the simplicity, I'm going to just copy this code, and then I'm going to paste it here. Once I paste it here, then I'm going to check it for the GT 1000. Then you have their 1000, and then similarly you have their GT 1000. Then there we have 1000 as well, and after that I think we have there from, let's say, 1000th case, and then here we have also 1000, there we have also 1000, and then there we need to put the 1000th case, and that's the 1000 case. All right, let's go ahead and check it again. We have GT 1000, countries day wise confirm 1000, 1000 is here, and then 1000 is here, and similarly we have 1000, 1000, there is 1000, 1000s. All right, so how it is going to work, we had first calculated, taken the countries which have at least 1000 cases, then we have filtered out the cases, okay, confirmed cases based on those 1000. I mean, then we had summed out those cases, and then finally we have taken the countries and minimum date, I mean the date when they recorded first 1000 case, and then we are going to plot after the 1000 cases. Alright, let's go ahead and plot it. Now once you plot it, you will see there these are the countries which have at least 1000 cases. Still it's the same as led by the United States. So in the next lesson, I'll show you how you can see it with a growth rate after the 10,000s and 100,000 cases. Alright, so in this lesson, I'm going to show you the growth rate after the 10,000 cases. So once again, I'm going to just copy this code from here and then I'm going to paste it here. Once I paste it here, again, I'm going to change it to 10,000. Let's go ahead, just copy it. I'm gonna make it 10,000. Then this is the 10,000. This is also 10,000. And after that, we have this as 10,000. This is 10,000. This one is 10,000. And this is 10,000. And this one is 10,000. This is all. Let's go ahead and plot this. So with this, we see the growth rate after the 10,000. So how many number of days has been for these particular countries when they achieved 10,000 cases. So these are the country. If you see earlier, we have been getting here Afghanistan and some other countries like Algeria and Argentina. But these countries do not have the 10,000 cases. That's why these countries are not shown there. We have there this country, that's the India. And then if you double click on the some particular country, all right, so there you see, so this is for Germany, all right, there is for India. And let's say if you want to see for the United States, so there you see for a different countries, all right. There you see with the Pakistan as well, all right. Perfect. All right. So this is all about in this lesson. Thanks for watching. In the next lesson, I'll show you growth rate after 100,000 cases. All right. Let's go ahead and analyze cases for 100,000. So we are going to do a same thing as we have been doing here for 100,000 cases as well. So there I'm going to put there 100,000. Then we have there 100,000. Then there we have 100,000. And there is one more zero there. And yes, we are going to put some more zeros there, and it's here. And then finally we are going to put it here. Let's go ahead and see the countries which have at least 100,000 cases. So these are the countries which have at least 100,000 cases of the coronavirus. So there is a linear growth in the cases of United States. Then there is the growth rate in the Russia. We have been also seeing there. Russia has the cases has been increased Russia drastically in recent time. And then we have here under other countries as well, like Spain, we have Italy, Germany, and France, and all those countries. And interestingly, you see there we do not have any Chinese here. This coronavirus originated from China, but we do not have any Chinese, any Chinese province or China as a country itself in these 100,000 cases. If you want to isolate some traces here, you need to double click here. Once you double click there on this trace, let me see how you can get those. Sorry. That should come actually with the double click. We have removed this one. Alright, so these are the countries which currently we are having. Anyway, so with the double click, we should see some particular countries. Yes. Alright. So this is all about in this lesson. Thanks for watching. In the next lesson, I'll show you how you can do a tree map analysis. Bye-bye. Take care. I'll see you in next lesson. Alright, so in this lesson, we are gonna see tree map analysis of confirmed cases. So we'll be utilizing Plotly Express tree map method. Let's go ahead and get started with this tree map. We need to first take a full data. So I'm gonna take their full latest data, which we have with df, and then there is df date is equal to max, and then we have their df, and then finally with the date. All right, then we have here fig is equal to px dot tree map, and in this tree map I'm gonna take the full underscore latest dot sort values. All right, and then we have here by is equal to confirmed cases, then there we have ascending is equal to false. All right, then I'm gonna reset this index. What is happening here? Actually, I have taken this full data set and the latest full data set, and then I have sorted the values by confirmed cases, and it is sorted in descending order. Then I have reset the indexes, and while resetting the index, I'm gonna put their drop is equal to true. All right, and then after that I'm gonna provide the path. All right, so the country is the path. So the path I'm gonna put their country, and then I'm gonna also put their province and state. And apart from that, I'm gonna put their values is equal to confirmed, and then we have their height is equal to 700. All right, so we have here a title is equal to number of confirmed cases. All right, then we have here color discrete sequence is equal to px dot colors. Then we have here qualitative dot dark 2. All right, so this is the color, okay, in a discrete sequences. And now I'm gonna put there fig dot data. All right, so either you can do like this, fig dot data, and then the 0 dot text info. All right, is equal to, in the text info we are gonna put their label plus text and then plus value. So there we are gonna put this value of this confirmed cases, and then this confirmed the country values. All right, and apart from this we are gonna just put their fig dot. So with this you will see there, I think there is some error. Let me see. Yes, it's here. Alright, so you have here tree map analysis for the confirmed cases, and in this you see the maximum cases are in United States. Then we have Spain, Italy and United Kingdom. Then we have here Russia as well, France, Germany, Brazil, Turkey, Iran, China, Canada, and there is India as well. Belgium, Netherlands, Saudi Arabia, Mexico, and all those countries which have a less number of cases. Alright, so this is how you can do for the confirmed cases. Let's go ahead and plot it for the death as well. So you can just copy it and then you can paste it here. Then you can give its name as death cases, and there I'm gonna put here deaths. All right, put here deaths, number of death cases. All right, let's go ahead and plot it. Once you plot it, then you will see there death cases. In United States, we have here 78.795 thousand death. Then we have UK, Italy, Spain, and France, Brazil, Iran, and other countries. Alright, so this is all about in this lesson. Thanks for watching. Alright, so in this lesson, we are gonna see what is the first and last case report time of the coronavirus. So let's go ahead and get the first date. Okay, so when the first day, first report of the coronavirus made in particular country. So we can get that with FRST underscore date. That's the first date. Then we have their DF. I'm gonna put their confirmed cases. Alright, greater than 0. That's mean when your first case occurred. And then I'm gonna put their first date is equal to a first date dot group by. All right, so there we have country, and then we had date. Then we are gonna create here aggregated values. All right, and then we are gonna reset the index. So with this, what happened, you can see there. Sorry, I think something is wrong somewhere. Let me see where it is wrong. It says that there is no key error. I mean, there is no key country. I think yes, it's wrong here. Alright, so with this you get their minimum date. So these are the dates when the first case is reported in these countries. So there are 185 countries in which these cases are reported, at least one. Alright, so there is first date, and then after that we are gonna take the last date when the cases are reported in the particular countries. So the last underscore date is equal to df dot group by, and then we are gonna put their country, and then date, and then we have their country date. So it is going to first group with country and date wise, and then finally I'm gonna take the confirmed cases and the deaths as well. I'm gonna take, and then recovered cases, and then finally we have here last date. So with this, you see we have got their pandas group. Then last date is equal to last date dot sum, and then I'm gonna create here difference there, and dot reset index. Why difference? I'll tell you. See, just a second. Let's say if a confirmed cases is same for a 2 consecutive day, in that case, that means there is no new case appear for that particular country. So if we take a difference of those confirmed cases from 2 consecutive day, then in that case, if confirmed cases are same, then what happens? Then it will be a 0. That means there is no case reported to in that particular day. All right. Perfect. So the confirmed cases do not, confirmed cases kept increasing. Active cases might get, increase and decrease. All right. So all these, whenever it says that the 0 confirmed cases, that means that is the last reported. All right. Last reported day for that country. All right. So we have got their last date. Now you see, we need to also make it for a the aggregated values. Okay, so we are gonna first create here a mask. In this mask, we are gonna get the country shift actually. I mean, we are gonna shift it by 1 day, and then we will compare whether new cases occur or not. So mask is equal to last date and then country. All right. So this is not is equal to last date country dot shift 1. All right. So with this, what you get in the mask, you get the mask whether it's the true or false. All right. That's mean when the two consecutive days are there, and if there is country for that one, whether it's a true or the negative. That's mean this says that you can make it something like this. So this says that in this last date data frame, take the country and shift it by 1 and then compare. If it is not equal to that one, then it's the true, and if there is a country, then it is a false. So in this way, we will reduce the total data set. So this is all about in this lesson. Thanks for watching. In the next lesson, we will continue this lesson. Alright, so now with the help of this mask, we are going to recover the last cases occurred in that in particular country. So we are going to put their last date dot log, that's mean the location, and then the mask. So it's the true and the false. If it is a true, then it is going to select that particular country. So we have dot log, and then we have their mask. All right, and then we are gonna get the confirmed column. Okay, and in that confirmed column, I'm gonna put their NaN values or a none value. All right, and similarly, I'm gonna put for the others as well. Let's say we have their deaths, and then here we have their recovered. All right, perfect. Let's go ahead and see this last date and see what happens there. All right, so NaN values are placed at those places where that mask is true. All right, perfect. Apart from this, what now we are gonna do there, if you want to take some random samples, you can also take some random samples. All right, so these are the some random samples. You see there was NaN value inside there somewhere. With this, it's difficult to find out those places where those NaN values are. Anyways, so you have this one. After this, what we are going to do there, last underscore date is equal to last date. Then we are going to select where confirmed cases are greater than 0. So last date, and then we have here confirmed cases and where it is greater than 0. All right, and in this way you will get there at least one confirmed cases. All right, now we are going to do a group by. So let's go ahead and do a group by. Last date is equal to last date dot group by. All right, and then with this you have their country, and then there is date dot aggregated values, and then you have their max. All right, and then you have their reset underscore index. All right, so with this, what you get there, now this will be grouped country by country, and then a maximum aggregated value will be taken together. All right, you can also see it with last underscore date. It says that something is wrong. I think yes, the 2 times group by is there. All right, so these are the max date when it is reported at least one case. See, there is a country Angola is reported on 8th of May, the last case. and this reported on the 7th of May, and this Western Sahara reported on the 12th of April. Alright, so this is how we have got the list of countries which have reported the last case. So this is all about in this lesson. In the next lesson, we will start about the aggregating all those data together, minimum and first and the last date, and then finally we will plot this in a bar plot. Alright, so I'll see you in next lesson. Alright, so now we are going to combine this first date and the last date together in a single data frame. So there I'm gonna write the name as first underscore last is equal to pd.concat, and then we have their first date. Okay, so first underscore date, and then we have their last underscore date. All right, so let's, in fact that should not be inside a quote. So we have their first date, then we have their last date, and inside that last date we want just a maximum column, that's the max date, I mean the latest date of the COVID report. Alright, now after this what we want here, we want their we want to put it on the axis is equal to 1. Alright, let's go ahead and see then first and last. With this you will get there, this is the first report date and this is the last report date for that particular country. Perfect. Now we are going to get the difference, and then we will calculate the total number of days in between these max and the minimum. So to do that, what we need to do there, we need to one more thing, we are going to add 1 day here so that we can report it correctly, because we are let's say we are making this tutorial today, and for the tomorrow and the today itself it's just a 0 day, so it's gonna be I'm gonna just add there 1, so which will show the next day as the day on which last the case appeared. Alright, so there we have a first underscore a first and last, then we have their max is equal to first and last, then there is max, then plus time delta. So in the time delta I'm gonna put their days is equal to the 1. So this time delta generates 1 day, and then that 1 day will be added in the max, and then you will see there is next day. Alright, so with this we will get a complete actually the difference. Alright, perfect. And in this way what we are gonna do, we are going to get the number of days. So the first and last, then we have their days is equal to first last, and inside that I'm gonna put the max minus first last, and then I'm gonna put their minimum. So with this I'll get the latest the first last, that's when there is a days, how many days has been there in between minimum and the maximum. Alright, so the total span, and this is the last reported day. Alright, so with this we have got the first and the last, and now we are going to rename these column. So how we can rename these column? One more thing what I'm going to do there, I'm going to also add one more column there. So I'm going to just put there first underscore last task is equal to first last, and then country. I'll tell you that when I plot that why I added this task there. Then we have there a first underscore last, then there is we are going to actually rename the columns. So there we have columns first last columns is equal to first one is country itself, not a problem, and then we are having here start day, and then we are having here finish day, and then we are gonna add there how many days it took from start and finish, and then we are gonna finally add their task. Alright, now let's go ahead and sort it by number of days. So I'm gonna put that first underscore last is equal to first underscore last, then we have here first last dot sort underscore values. Alright, so there I'm gonna sort it by days values. Let's go ahead and see this first and last. So this is sorted by these days values. Alright, so the maximum span, it is saying that in United States 109 days. So it has been 109 days since the first case appeared. At least 109 days. In fact, that could be the larger, but in the data set, which data set we have, data set is recording from the 22nd January 2020. Alright, now what we are going to do here, now we are going to write the visualization part. So for the visualization part, we are going to write there, we are going to first create random colors actually. Alright, so we have there colors is equal to, there I'm gonna add here first hash value, then I'm gonna put there plus sign, so it will make, add the 6 hex digit numbers together. Then I'm gonna create there a random choice in between the hex digits, that means 0 to 9, and then A, B and C. Alright, so with this what I'm gonna do that, I'm gonna put there the choice dot join actually. Alright, and inside that join I'm gonna put there random dot choice. Alright, and inside that we are gonna put the numbers which we are gonna take there, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, and then we are gonna put there A, B, C, and let's go ahead and put the D and E number as well. So, and I'm gonna also put the F. So this is all the digits together, and then I'm gonna use here a for loop for J in range of 6. Alright, then for I in range of len. Alright, so length of first and last. I'll tell you why I did that, because you see I want to run this for all the rows so that it can generate random colors for all these rows. Let's go ahead and run it. Once you run it, then you will see inside these colors. So these are the random colors which we have generated. Now we are going to use these colors in our bar plot. Alright, now we have their fig is equal to ff, that's the figure factory dot create. Okay, so I'm gonna create here, you see there we have create, we should have here, create Gantt, and then inside this Gantt we have there a first underscore last, and then here we have index underscore call is equal to country. Alright, and then there we have colors is equal to CLR. Alright, and then there we have show underscore color bar is equal to false, and then here we have bar underscore width is equal to 0.2, and then here we have their show grid is equal to show grid underscore x, that's mean for the x-axis. So I'm gonna make it true, and then show grid underscore y, that's also I'm gonna make it true, and then the height for this plot I'm gonna set it 2500. Alright, and then finally I'm gonna set here fig.show, and it says that, sorry, that's the color actually. We had taken their colors, sorry. Now it will take a little time to complete this plot. There you see here we have this full plot. Alright, so with this we can also change it in the the 1 month, 6 month, or a week, etc. So let's go ahead and change it for a 6 month, and in this last 6 month, what we see there? We see the total lifespan for this coronavirus, the last date it is reported, and in this Taiwan country, you see it is reported, I think 8th May, okay? So yesterday it was not reported there, and there is 8th May there in the Vietnam as well. And then here we have a Cambodia. So last corona case reported in Cambodia is 13th April 2020. And you see there we have other countries as well which had perhaps overcome from the coronavirus, like Bhutan is there, and then we have here Trinidad, and then here we have a Mauritius, then we have a Papua New Guinea, and all other countries here. So these countries has not reported quite some time any COVID cases. Alright, so this is all about in this lesson. Thanks for watching. I'll see you in next lesson. Alright, so now we are gonna see confirmed cases, country and day wise. We can see these cases with temp is equal to country underscore day wise dot group by, and there you have country and then you have date there. Once you have got these, then we are gonna get their confirmed cases. Alright, so we have got here confirmed cases. Let's go ahead and sum it, and then finally reset underscore index. Alright, so first let's go ahead and see the head of country day wise. There, this is head, and then we are gonna sum it by country and date, and then finally we are going to take the data for only those countries which have the confirmed cases at least 10,000. So country, alright, is in, if you remember, we had this GT underscore 10,000. Even you can also make it for 100,000 as well. Alright, and then I'm gonna get the countries, list of countries for which we are gonna plot it, so that we can get with temp country dot unique values. So there, these are the countries which have at least 10,000 cases. Now we are gonna plot these in a 3 by, and the total are the 3 columns in each row. That's mean I'm gonna put there n calls is equal to 3, and then n rows I'm gonna put there math dot seal, and then the total length of these countries and divided by n calls. Alright, now I'm gonna add this figure. I'm gonna make here subplot. So figure is equal to make subplots. Then I'm gonna pass their rows is equal to n rows, and then calls is equal to n calls. There we have shared x-axis, so that's I'm gonna make a false here. And then here we have subplot titles. subplot titles will be displayed there country by country. So that's the countries. Alright. Perfect. Now let's go ahead and create here a for loop so that we can print plot for each of these countries. So for index, then here we have country. In enumerate, so we are gonna enumerate these countries. So we'll be getting here these country names in this country variable and the index location in this index data. So there I'm gonna make here row is equal to integer format of this index divided by n calls. Alright. And then I'm gonna add here +1. Then call is equal to, we have there int modulus operator as n calls and then +1. So with this we will be getting here rows and the column. Alright, now let's go ahead and add these figures. So fig dot add underscore trace, and inside that I'm gonna add there go dot bar, that's mean plotly graph object. I'm adding there bar plot. So x is equal to, we have temp date, and then y is equal to temp. One more thing, we will be taking here cases for all the countries. So there we have temp dot lock, and there we have there temp. All those countries which are equal to these particular countries, any of these particular countries, which we are gonna set by this country. And once we get this, then I'm gonna take the confirmed cases there. Alright. And after that, I'm gonna plot here name is equal to country. And then here we have row is equal to row and call is equal to call. So that's gonna be taken from this for loop. And once it is done, then we are gonna update the layout with the height and with its legend out of this for loop. Then here we have fig dot update. Alright, so fig dot update underscore layout, and in this I'm gonna put the height is equal to 4000, and then we have here title underscore text. This is going to be a confirmed cases in each country. Okay, perfect. And then finally we have here a figure dot update underscore layout. So there we have show legend is equal to false, and then finally we have here figure dot show. There is an error. Let me see. It says that key error. There is countries is key error. Let me see there. I think here that should not be the countries, but in fact this should be country. Alright, so it might take a little time to process all these graphs because the total number of countries which has passed 10,000 cases are huge, and those will be plotted here. Just a second, now it has came here. We see there we have Austria, Bangladesh, Belarus, Belgium, Brazil, Canada, Chile, China, Colombia. And with these now you see the confirmed cases has been flattened out in the China, and apart from the China, in all other countries it is still increasing. And in the Belgium, it also seems that they have flattened the curve. And there now you see in the France and other countries, there is still it is increasing. In India now you can see it is increasing there exponentially. In Indonesia you have there, in Iran, Ireland, Israel and Italy. Japan has been also flattened out. South Korea has also flattened their curve as well. And in other countries this coronavirus is still increasing with the exponential rate. As you see here in the Pakistan, it is also increasing. Alright, so these are the cases where it is still increasing. We have here US as well, Turkey and Switzerland. Alright, so this is all about in this lesson. Thanks for watching. In the next lesson, I'll compare this COVID-19 cases with other similar epidemics. Bye-bye. Take care. I'll see you in next lesson. Alright, now let's go ahead and do some analysis with COVID-19 versus other similar epidemics which had happened in recent years. So we have here a similar epidemics like COVID-19, SARS, Ebola, MERS and H1N1, which is also known as swine flu. COVID started in 2019, in the last days of the 2090s, and then the SARS started with 2002 to 2004. Then we had the Ebola, which started in 2013 to 2016. Then we had the MERS, which had started from 2012, and still a few cases are coming from MERS as well. And then we have here H1N1, which started in 2009, and then finally it ended in 2010. Alright, so these are the start, end and the epidemics, and there are the confirmed cases. So these cases are taken from the Wikipedia. Alright, Wikipedia is a source for all these data. Then we have here a full latest. Inside this full latest, we are going to, these are the full latest data which we had earlier actually. You see there in this lesson we had created that full_latest. So these are the latest data, alright, for all the countries together. Okay, so there we are going to sum the confirmed cases and then we are going to sum the total number of deaths for all the countries together. And then we have values for other data points like SARS, Ebola, MERS and H1N1. Let's go ahead and create the mortality rate. So we have here epidemics. We have there a mortality rate is equal to round. Then we have epidemics. Then there we have deaths. Alright, then here we have epidemics and then we have here confirmed cases. Alright, perfect. Then here we have epidemics dot head. Alright, so with this we have got the data frame for this epidemics. Now we are going to plot it into a figure and we can plot it with the melt plot. So the first I'm gonna create here a temporary variable, then I'm gonna melt actually the pandas data frame. Okay, then here we have a ID. There I'm gonna put their epidemics. Then here we have value variables. So the value variables we are gonna put there confirmed. Okay, so see there we have confirmed cases, and then we have their total deaths reported, and then finally we have total mortality here. Alright, and then here we have variable name. The variable name is case there, and then here we have a final value underscore name. So there it is, a value. Alright, let's go ahead and run this. It says that there is some error. Let me see. So it says that passing list likes to lock with any missing labels is no longer supported. Let me see where it is throwing the error. I think it is throwing that error here. I think we have ID is equal to the epidemics. That's the right here. Values, variables, we have their confirmed cases, death cases, and mortality. That's okay. Variable name, we have cases. Value name, here we have a value. I think this is right. This should run. Alright, so I got the error. That error is here. I'm passing here this epidemics actually. So that should be the epidemic. Alright, let's go ahead and run it. Now this is working fine. And then there we have here our temp variable. Alright, so this is melted here like epidemic. These are the epidemics. And then here we have a cases. And then these are the values. Alright, now what I'm gonna do here. So I'm gonna do here a fig is equal to px dot bar plot. Then I'm gonna pass here temp x is equal to epidemic, and then here y is equal to value, and then there is color is epidemic, and then there is a text, and in this text I'm gonna pass there a value, and then I'm gonna also use their facet color. Okay, so there I'm gonna change these facet color along with the cases. Alright, and then here we have a color sequence, color discrete sequence, and there I'm gonna pass px plotly express dot colors, then dot qualitative. Alright, so qualitative dot there is bold. Alright, so once we have this figure, then we are gonna update this figure. Fig dot update underscore traces, and there we are gonna put text position is equal to outside of the plot. As you see there, we have their confirmed cases, death, and mortality rate for all these the epidemics. So we had their H1 and N1. Confirmed cases was really very high, but the total number of deaths was only the 19,000, but their mortality rate was too low. But COVID-19 mortality rate is quite high, and the total cases are also quite high. So in a very recent time, we have not seen any the cases like this. Now what I'm gonna do here, I'm gonna also increase the bar for these case of mortality cases. That you can do very easily. So I'm gonna use their fig dot update underscore layout. Then I'm gonna put their uniform text. Alright, underscore min size, and that I'm gonna use their 8, and then I'm gonna put their uniform text underscore mode. I'm gonna put their hide. Alright, and then here we have a fig dot update underscore y-axis. Alright, so there we have actually y-axis to the first one is y-axis Then I'm gonna put there so tick labels is equal to false. So tick labels is equal to false, and then here we have a fig dot layout dot y-axis. All right, so y-axis 2 dot update, and there I'm gonna put there matches is equal to none. And similarly I'm gonna do that y-axis 3, that means this is y-axis 2, this is y-axis 1, and this is y-axis 3. So fig dot layout dot y-axis 3 dot update matches is equal to none. Why it is important? Because you see these are matching these numbers. That is why these numbers are these bars are not coming here. Alright, and then finally I'm gonna write there fig dot. So let's go ahead and run it. There is an error. This error says that, let me see what is this error. So it says that there is invalid property. I think something is wrong here. Alright, so there is a mistake here, uniform text underscore min size. Alright, now if you run this, you will see it here very clearly. We have a confirmed cases, death, and the mortality. So we have a highest mortality rate in case of the Ebola, and then we have a mortality rate for a MERS, that is 34%. But the total actual number of deaths have been very less in case of these epidemics. But in case of the COVID, we have here, very large number of deaths. So there we have total 2.79. Total we have 279,000 deaths. Alright, so this is all about in this lesson. Thanks for watching. I'll see you in next lesson.